Question 18. The diagram shows two spheres of mass m suspended from wires of negligible mass. The length between the pivot points and the centres of each sphere is L. There's two suspension points lie on a horizontal line and are separated by a distance x. This system is in equilibrium. Take the total acceleration due to gravity to be g. You may assume that delta x is much smaller than L and delta x is much smaller than x. Show that the small deflection delta x by which the gravitational force Fg between the spheres will deflect them from the vertical is given by delta x roughly equal to, and then this equation, where g is Newton's gravitational constant. Clearly state all assumptions you make and show all your workings. So, let me just zoom out a little bit more. So, part A. So this has got quite a big question, but the first thing I'm going to do is I'm going to label my diagram a bit more. I'm going to call this a T here. And we have a gravitational force here, and we have a weight here of mg. So we can turn these into kind of equations of motion, where we know that T cosine theta, like this force, the vertical force here, equals mg. Okay, and then we also know that this is resolving up, and then we have resolving that way. We have T sine theta equals the gravitational force here, and the gravitational force is F equals G mm, so m squared, over the distance between them, which is x minus 2 delta x squared. So I'm going to say T sine theta equals this. G m squared over x minus 2 delta x squared. So this is just Newton's gravitational force formula. So we also know that from this kind of triangle here, we know that L sine theta equals delta x. So we know that delta x over L equals sine theta. But because this is a small angle approximation, we know that this roughly equals theta, okay? But another small angle approximation is we know that tan theta also roughly equals theta. So this roughly equals tan theta as well. So you'll see why this will come in useful later. So if we just have equation 1 here and equation 2 here, what we can do is we can do 1 over 2, or in fact 2 over 1, which equals g m squared over x minus 2 delta x squared, multiplied by 1 over mg. We know that this equals t sine theta over t cos theta, which is just equals tan theta, okay? Which roughly equals delta x over L. So we then have gm squared over x minus 2 delta x squared times 1 over mg equals delta x over L, okay? So expanding this thing down here, we have gm squared over x squared minus 4x, minus 4x minus 4x delta x plus 4 delta x squared times 1 over mg. Okay. So, yeah, that's that. Now what we got to do is multiply through by the g. So we know that delta x over L roughly equals, and then this cancels with this here. So we have gm over gx squared minus 4gx delta x plus 4g delta x squared. Now, if we look at this here, delta x squared, we can assume that this is 0. And the reason why is because we know delta x is absolutely tiny. It's like very, very small number. So we're just going to like not ignore this term. And also, if you see here, if we then multiply through by delta x, multiply through by this, we'll get a quadratic in delta x squared, which is what we want. So let me just trim this up. All right. So then multiplying through, we get LMG, big G, equals G x squared delta x minus 4xg delta x squared. And the reason we're not putting this delta x to 0 is because we can clearly see up here that this is like comes from a quadratic, so we're going to keep this until we solve it. But it's just if it's cubic, then it makes it a lot more complicated. So then if we move all these to one side, we can see that A equals 4xg, B equals minus gx squared, and C equals lmg. So then solving for delta x here, if I've just added this and minus that to the other side. So then we know that delta x equals minus b plus or minus the square root of b squared minus 4ac, which is 16xg lmg, all over 2a, which is 8xg. So we can split this off into these two terms here because this term can split off. So we know that the g cancels, one of the x's cancel, so we just get x over 8, which is a good sign. That's what was in our original formula. Plus the square root of g squared x to 4 minus 16x glmg all over, and I'm going to move this inside the bracket so I can make more cancellations, so I get 64x squared g squared. So then this equals x over 8 plus or minus the square root. So in this we can see g squared cancels with, in this term here, sorry, g squared cancels with g squared, x to the 4th x squared. So then we're just left with x squared over 64 minus, in this one here, we can see the 16 and 64 cancel, x squared, g squared. So we're just left with lmg over 4gx. And what do we have here? Oh, okay, so there we go, we basically have it. So we have x over 8 plus or minus the square root of x over 8 squared minus lmg over 4gx. So then what we have to do is we have to like look at this and see why they've chosen the negative solution. And the reason why is if we look at delta x here, we know that as the mass goes to 0, okay, we know that this term here, well, we know that delta x will have to go to 0, okay? And the reason why is because if the mass is completely 0, then it will just be like hanging down, so delta x will be 0. So what satisfies that? Well, if m equals 0 here, we have delta x equals x over 8 plus or minus x over 8. So the only way for this to be 0 is if we choose the negative solution. So that's why it's a negative. Okay, so we say, therefore, delta x equals this with the negative. Okay, so part B. This says, spheres are now both electrically charged with the same positive charge Q. How big must Q be so that the wires will hang vertically again? Hence, the force between the two spheres electrically charged is given by FQ equals K, Q1, Q2 over R squared. Okay, so this is just like what they said here. So we know that this is counteracting the gravitational force, because the gravitational force is going that way. We know the electrical force will be going this way because they have the same charge. So we just know this has to be equal to Gm squared over R squared, and this is not Q1, Q2, this is QQ, so Q squared. So multiply through by R squared, this, these cancel out, and then we just get Q equals square root of Gm squared over K, which equals M root G over K.